Pydantic AI agents resolve runtime context into dynamic instructions through the RunContext abstraction, letting a single toolset inject personalized guidance by threading dependencies into the model request. A function toolset registers both callable tools and instruction functions, where the @toolset_instructions decorator produces a string that the agent appends to its prompt on each run. The artifact below demonstrates constructing a typed toolset with a context-driven instruction function and a plain tool, instantiating an agent with a deps type, and executing a synchronous run that passes a dependency instance to produce a personalized instruction string. From Pydantic AI import agent, FunctionToolset, RunContext. From Pydantic AI models, test import test model. Math toolset equals FunctionToolset SDR. At math toolset instructions. Def math instructions text. RunContext SDR. Return FU are helping. ctx.deps. Always show your work when using the calculator. At math toolset tool plane. Def calculator expression. SDR. Evaluate a math expression. Return 4. Test model equals test model. Agent equals agentist model. Toolsets equals math toolset. Deps type equals SDR. Result equals agent. Run sync what is 2 + 2. Deps equals Alice. Print result, all messages 0, instructions. You are helping, Alice. Always show your work when using the calculator. A function toolset registers a dynamic instruction function via @toolset instructions that receives RunContext SDR and interpolates ctx.deps into its return value. The agent is constructed with deps type equals SDR, and at runtime agent runsync is called with deps equals Alice, which populates ctx.deps inside the instruction function. The toolset also registers a plain calculator tool via @toolset tool plane, which doesn't need RunContext since it has no dependency access. The pattern separates static tool behavior from dynamic instruction context, letting the same toolset serve different users or sessions without duplicating instruction strings. The trade-off is that instruction functions reevaluate on every run step, which is fine for simple string interpolation, but could add overhead if you're doing expensive lookups. In production, you'd typically gate heavier logic behind async checks and memoirs where possible. Let's break it down. From Pydantic AI import agent, function toolset, RunContext. From Pydantic AI models, test import test model. Imports agent, function toolset, and RunContext from Pydantic AI, plus test model from the test models module. These provide the core agent class, toolset wrapper, execution context, and a mock model for testing. Math toolset equals function toolset SDR. Creates an empty function toolset typed for string values and binds it to the name math toolset. At math toolset instructions. Def math instructions text. RunContext SDR. Return FU are helping. ctx.deps. Always show your work when using the calculator. Registers a dynamic instruction function that, when evaluated at runtime, returns a prompt telling the LLM who it's helping the deps value and to always show its work when using the calculator. At math toolset tool plane. Def calculator expression. SDR. Evaluate a math expression. Return 4. Registers a tool named calculator that accepts a math expression string and returns the literal string 4. The docstring describes it as evaluating a math expression, but the implementation ignores the input and returns a fixed result. Test model equals test model. Instantiates test model and binds the instance to the variable test model.
Agent equals agentist model. Toolsets equals math toolset. Deps type equals SDR.
Creates an agent instance named agent configured with test model as its LLM, math toolset as an available toolset, and declares SDR as the dependency type for static type checking.
Result equals agent. Run sync what is 2 plus 2. Deps equals Alice.
Invokes the agent synchronously with the question, what is 2 plus 2? And passes Alice as the dependency instance, storing the returned run result in result.
Print result, all messages 0, instructions. You are helping, Alice. Always show your work when using the calculator.
Accesses the first message from the collected run results and prints its instructions, which read, you are helping, Alice. Always show your work when using the calculator. The whole flow is one pipeline. Deps type declares what dependency shape you're working with. FunctionToolset SDR binds that shape to a toolset. At toolset instructions, captures it at runtime through RunContext, and agent runsync delivers the actual instance. The instruction function and the plain tool live in the same toolset but operate on different axes. One reads ctx, deps, and reevaluates each step. The other just does its job. That split is the design win. Same toolset, different users, no duplicated strings. The cost is reevaluation overhead on every run step, which is fine for simple interpolation, but worth memoizing if you're doing real lookups.
The calculator whispers 4 before the question forms, while RunContext weaves Alice into every instruction.